Okay. Hey, everyone. Welcome back to another episode of the LlamaIndex webinar series. I'm super excited today to help host Wey from NebulaGraph. We'll be talking about graph databases, NebulaGraph, and how this affects the kind of ongoing retrieval-augmented generation stack. And so these days, everybody's using vector databases and LLMs. How do knowledge graphs and graphs kind of play into this world, and how can they help you create augmented retrieval and synthesis with your QA and chatbot application? So without further ado, I'll pass it over to Wey.
Thank you, Jerry. And I will share my screen. Okay. So we can see it, right?
Yeah.
Okay, thank you. Thanks a lot, everyone. And I'm super excited to have this chance invited by Jerry to share something around what we had been doing around the graph-related RAG in LlamaIndex. So this and our slides is actually in public, this URL. So if you want to check back and forth, you can do it. Okay, so we will have this schedule in 3 parts. So I will quickly go through the overview of the graph, the background, and then I will give a brief introduction on what we had done towards LlamaIndex. We add some extra abstractions to enable the graph on language module development. And finally, we will have the QA session with Jerry. So we will have some more interesting things in the 3rd part. So stay tuned. Okay, so what is graph? I think most of us had already know. I've quickly walk you through. So the term of the definition of graph was initially triggered and mentioned during a study of an old question called 7-bridge problem. So that is an old city in Europe. So at that time, there were 7 bridges there across the rivers, and that make a segmentation of land in a couple of different parts. So the people are questioning that is there a traversal pattern that we can walk through all the lands without repeating walk on each bridges. So and when we were dealing with this problem, we finally will abstract the bridges into connections and the lands into a dot or a vertex or node. So this is the ultimate form of this problem in math. But why do we need such doing such studies on the graph? Actually, graph is underneath everywhere in our daily life. So one of the use cases is called knowledge graph. And the term of knowledge graph was initially invited by Google. So they want to improve the search result. And for example, if we search MCU Nebula, and we can see there are cars here. So these information are actually some form of knowledge, not just assembled from the pieces from different pages directly. So it's actually backed by a knowledge graph. So for example, if we search like Karen Gillen's age, yes, we got the answer of her age. So this apparently cannot be done with the the sorting on indexing of existing documentation. So it's also backed by the knowledge graph, the reasoning capability. So yep. But as you know, we have a layer called graph database. So why do we need such yet another database? So most of the arguments are related to how we want to retrieve data, like normally in graph database, we have some specific DSL to query the, towards the connections. For example, we do 2-hop queries. So we can do something like this rather than, the curse of the nested SQL, the joins. But this is just, just the inch, just to make you happier. So what makes it difference? Why we finally need some such database? I want to, add this inappropriate metaphor to, show. So imagine we were doing this old retro games called Snow Brothers, and I want to make this. We make us think of this is the So this is the traditional tabular database. So we will control the brothers to throw the snowballs to the monster, and every stage, think of every stage as a different table. And when we were doing the graph query, typical graph query like traversal from one node to another, so that's a underlying a join between tables. So we have to walk, jump, and run towards the monster, and that's typically what a tabular database is doing. But so we can actually add some new things, different things to run faster. So like creating different indexes, do a lot of magical things on the tabular storage layer, but it's not changing the fact that the join is expensive. So in our use case, we want to jump a lot of hoops, a lot of joins. So I want to make the metaphor that graph database is doing something like this green bottle, where we can actually fly. So in that case, we can fly from one point to another in a very cheap effort. And in graph database, we can consider this this join actually in almost 1 effort. So it's an inappropriate metaphor, but I hope it makes sense of why we need a graph database. So another question is, why do we need a NebulaGraph? So this is the project that I was mainly working on in my daytime. So it's an open source project. So I want to quote one of the from Martin from AWS. So so imagine this problem that we have a shape in this small river, and if we want to make it move forward, we just have one guy to push it. Yeah, but similar problems comes in different scale, can have totally different solutions. So think of this shape. It's called evergreen. So if you recall, it's a big ship blocked the whole world's transportation for a couple of months. So the problem can be solved in quite different ways. So NebulaGraph, this project is designed from day one to be distributed, to be targeting to solve the the hyperscale graph problems. And we are open source project. So when I was asking the users why they choose to use NebulaGraph, most of the answers are related to performance and the scale. Yeah. So yeah, we quickly finished the marketing part. Yeah, we come to the second part. So it's about the graph stores. The story started from the graph stores in LlamaIndex. So one of background is called the RAG, the main topic that we want to cover today. So the basic flow of the retrieval augmented generation process is we want to ask the language module to help us finish some sort of task based on some existing data that the module wasn't learned from. So the general approach here of the RAG is to split the data into different chunks, because we cannot, send everything to language module. And we create the semantic embeddings per each chunk and index them in memory or in vector database, which will enable us to, so this is during the build time. And when we are doing the query time, we want to solve our problems, we can make our task to generate the embedding, the semantic embedding of the test as well, and compare it to, like top K related chunks of this task. And when we get like top 2 of the chunks of the data close to this question, we send them together as a context to the language module. And that's what we were doing in the most of the cases, which worked quite well in most cases, right? So as a graph guy, we were playing graphs every day. What we are thinking here is our intuition here is we are dealing with knowledge, but knowledge is actually knowledge graph is a refined form of the graph, and it's also a fine-grained segmentation. It's a fine-grained segmentation of the the data or information, and it's also enabled the interconnection between the entities, the the small segmentation of the knowledge. So maybe it can make some difference. So this is hypothesis, and maybe we can try to bring the knowledge graph in this stack, in this paradigm. So another thing is building such knowledge graph was relatively expensive and involves a lot of expertise. So maybe we can get help from the language module as well. So with this iteration, we want to make some, bring something in this workflow. And if we look into this data part, and if we extract the knowledge graph from those information, we can see, yes, they are entities or terms per each chunk. And so imagine if our task or our question is related to one piece or 2 pieces of, for example, X. But if we are doing the the traditional vector split method, so maybe we cannot cover all the information related to X in like top 3 or top 5, right? And on the other hand, if we abstract, after we abstract the knowledge, what we have in knowledge graph, we have the connections between the terms, and that will bring the possibility, the capability of the cross chunk context. So this is sometimes matter. So with this hypothesis, we are doing something, and we try to bring the knowledge graph to the picture, and our initial verification shows quite relatively promising results. And if we look back to this workflow, we just get the knowledge graph, the relations between the entities, the small pieces of the knowledge, as the context to be sent to the language module. Yeah, and to do that, and we collaborate with the community of LlamaIndex. So we define a new storage called called graph store, and so this is the legacy vector-based index creation code. So, for example, we create one of the vector database backed vector index, and similarly, we can do quite equivalent pattern of the coding. So we just create a knowledge graph storage backed index called knowledge graph index. So with the help of this abstraction, we not just bring the knowledge graph to the RAG. We also solved another problem that we mentioned before. Oops, here. Yeah, the building of the knowledge graph, the extraction, the small information from the text is also quite expensive. So we, after we introduced the graph store, this step, the end-to-end step was all included in the LlamaIndex ecosystem. So this line is just when we are doing indexing of our data, and after that we will have a up and running. We not just can do the RAG, we have a up and running knowledge graph and persist in the graph store. And here we were using knowledge NebulaGraph, of course. And this is the during the query time, we can just use the high-level API of as query engine to convert the knowledge graph index into a QA endpoint. So, for example, we ask a question here, and so this is the very first twist that goes viral about our work, and we can see here. So this is the oops. Okay, this is the index creation of the graph store. So we set we leverage LlamaIndex. We extract the the entity and the relationship between the entity from documentation and persist them in NebulaGraph, and then we do the query. So what graph is sweet thing here is it brings the transparency, the traceability and the explanation during the whole thing. For example, we can see from the log that it abstract the entities from the question. So there are 4 of them, and then it will query the knowledge graph to get all those in maximum depth 2 graph queries. So then it combine all those retrieved graph structured context to finally compose the answer as so. And what's interesting is here if we do the equivalent query of these entities to get the maximum two depths graph query, and we got the result from the knowledge graph. Yeah, we can create other stuffs based on this knowledge graph, of course. And one of them is we can visualize them quite easily. So that's a quite interesting side effect of this work too. So yeah, as I mentioned, we want to improve something around RAG in LlamaIndex with graph. And we also get a side effect to actually build the knowledge graph. Actually, there were some papers released around how we want to leverage the large language modules to change how we were doing now to doing this build, the setup of the knowledge graph. So this is another place that we can also get help from large language module, not just extraction. So this is a traditional QA system called knowledge-based QA system. So here knowledge refers to knowledge graph. So previously what we were doing here is we are doing a lot of hard works to extract the semantic information to detect the intent of the question or task, and finally create knowledge graph queries, and make the knowledge graph queries directly, to assemble the final answers. So this is the traditional way when we're doing the KB QA system. And when we have a language module, all of those hard works can be done by just prompt engineering. And this is quite another exciting things we can do, with the graph bring in this picture. So we already have things called the NebulaGraph QA chain in LangChain, but to be easier to bring everything connected, we also have a equivalent thing called the knowledge graph query engine in LlamaIndex, and we are still working in progress of this PR. So this is only the draft of what we already achieved. So basically, we can create the knowledge graph as we already demoed. So first, we fetch the the information. So this is a simple version of workflow we were doing the KBQA. So we leveraging the Llama Hub, so it's a part of the LlamaIndex community. We can easily get the information from the Guardians of the Galaxy Volume 3 film. So it's my favorite. We can easily fetch the information from the relatively long Wikipedia page, and then we create a knowledge graph with this one line, with the knowledge graph index, and then we and then we create a query engine called knowledge graph query engine to directly connect to this graph store, and then we can query the question like, tell me about Peter Quill. So this is and the QA question will be translated by the this query engine into a graph query, and this is the response from the knowledge graph, the Nebula graph, in a cipher result, and then we assemble the result into the answer, of course, and we can also query them by ourselves. So we do the exactly same query, and this is the result, and we can visualize it. So it's quite interesting. So this is even easier for user to understand the result, the answer of this query, actually, from my own opinion. Yes, I think that's all from the first two parts. Yeah.
Wait, this is fantastic. And I think the slides are up. So if you want to take a look, please feel free to go through. And I know there's a bunch of stuff in there to go through, including links and notebooks that you can play with. And so we're super excited about the upcoming integration with GraphQA with LlamaIndex. So this is awesome. Let's jump to just like a few general questions, and we'll leave some room at the end, like 5 to 10 minutes for questions from the audience as well. This is a very basic question. But going back to this like overall idea of graph databases and ignoring LLMs for now, what are some of the real life practical use cases for graph databases, and how do they compare to, for instance, like a SQL database, object store, or like a vector database in kind of like the traditional data setting?
Oh, yeah. So actually, in the in the graph community, we are withdrawing a lot of different new use cases, from different domain industries. They're leveraging the graph capabilities to do the cool stuff, but there are already out there like around 20, I would say, state-of-art solutions to leverage the capability of the graph. So for example, we can do added mapping. So if you have a user system, so you want to identify some of the user are actually controlled by some of the username are actually controlled by one person, and that can be done with graph beautifully. So for example, fraud detection, if you want to detect, you have a user content system of fintech e-commerce system, you want to detect the pattern of a certain fraud. So most of them can leverage some sort from graph. For example, in So I won't walk through every slide here, but it's an example. So if we module this problem in graph, and we can do simply query to know, this is a one person or one device related to a bunch of different actions. So this can be in a higher risk. So this is the query-based problem solving. So another pattern would be, for example, yeah, I can demo one of them. For example, we can leverage the graph algorithms, like we query some of the information. So in this is still a fraud detection problem. So we can do like a Louvain algorithm. So this is the algorithm helps you detect the the clustering of all those components, the entities. So here, after I run this Louvain algorithms, it will, so in a visualized sense, it will color the things for us, but underlying they are marking different entities in different labels. So these can be a great input on a next hoop of the pipeline, or as one of your feature in your machine learning modules, because the clustering information makes a lot of senses in these problems. So for example, we can further run a PageRank algorithms. So that's that's a simple and old algorithm help us to find the nodes or entities importance information. So this is also very important input. So that's this is just one small view of all the use cases. So maybe another one. Yeah, we can also do the graph neural networks towards data persisted in graph databases. But GNN, graph neural networks, not necessarily to be collaborated with graph database. But with the graph database, something can be done differently. Let me find that one. Yeah, so this is an example that I create a demo project to leverage GNN and the NebulaGraph to do a real-time fraud detection with GNN. So we trained offline. We trained the module in GNN. The module will help us inference which node is with a higher possibility to be risky. And in the real-time case, we have a transaction to our system. We insert them in our graph, and we in real time we can query the subgraph like in a couple of hundred of MS, and then we put this like 3,000 nodes subgraph to our module that we trained before. So this can be done in real time. So so the graph database in this phase enabled the real time of this whole workflow. So when we come back to the question that the differentiate between the different type of databases, I would say in some cases they have the overlap. For example, we can in theory persist the structure of the graph in tabular database. We can do that, but if our use case are related to multi hoops or arbitrary connection between two entities, so it's really hard to be done with SQL. And when your data is in hyperscale and you are doing in a high concurrency fashion, so it cannot be fulfilled in a tabular way. So another case, but when we want to do some analytical thing or mission critical transaction tasks, we can somehow do in graph database, but it's not that perfect. We have the consequence, we have the trade-off to persist data in a connected way, but we are not in a best way to do in a tabular query. So speak of a similar apply to like object store and the vector database. So vector database it excels at the top key embedding searching. So the embedding, to me, even let's back to the language module landscape. So the embedding based the distance searching performs much better than the graph based semantic query, because by nature most of our simple or few short questions are related to information data aggregated together. So in that case, if we split them into small triplets, so that's not the best fit for that. But in some cases we can maybe we can combine them, but we are still discussing and exploring that. Yeah.
So awesome. That was a really detailed answer. And actually following up on that last point about vector databases and graph databases. So now kind of going to the LLM use case of retrieval augmented generation, where by default, I think most users these days are probably adding a vector database with an LLM to build, for instance, like an LLM QA system or chatbot. What are your thoughts on the pros and cons of graph databases and vector stores? And could you elaborate on some of the trade-offs a little bit more? And then the second part of this question is, are they mutually exclusive? Could you actually use potentially both of them to create better retrieval of your results for LLMs?
Yep. Yes. So I think in this domain, so the semantic, the vector-based database or store excels at the semantic search when it comes to gather the information in the information spread. But when we are doing the distance search based searching, we are actually compress the complex form or structure of the information into one dimension. So that is the closeness of the distance. So this will somehow in our intuition lose the information of the structure itself. So we consider, as we know, the word is structured in a graph way. So some certain sort of task or questions, especially in QA case, could benefit from the when we leverage the graph structure. So and the second question is, are they mutual exclusive, and can they be used together? Yeah, and I think you already know the answer. They are not, and they can be put together. So let's look back to the RAG process. So what if we put the knowledge graph-based retrieval together with the vector-based retrieval? So as we already shared in the LlamaIndex documentation, we can see. So here we leverage the beautifully abstracted customer retriever from LlamaIndex. So we finally create a customer retriever that will retrieve both the vector-based RAG and the knowledge graph-based. And finally, we combine the two. And our result is showing that, for example, we are querying one question that we, in this case, we pass the data. We cherry pick data that's created newly after the GPT training. So it's about the science events in the Wikipedia in this year. So we are asking about the NASA. So tell me the science events about NASA, and we can see the vector store works excellent, and it comes with some fruitful and correct answers. But still, here we found the purely knowledge graph-based RAG can abstract smaller pieces of the information that's not covered by the top K searching of the vector base. So after we combine two, we indeed find the answer is somehow better. And in this case, the actual effort with the graph-based RAG introduced is just like around 7% of more tokens. So this is just not that full evaluation, but it brings some, promising direction to us, because, we didn't fully exploit the K knowledge graph RAG yet. We are just doing some keyword string matching based. It's already showing some results. And on the other hand, the pure KG RAG is also interesting. So we think in the future we can somehow put the two in one view, and to help fulfill some long or difficult QA tasks. Yeah.
Awesome. And the follow-up question to this, actually, which I'm very curious about, do you think there's plans to integrate, for instance, embedding vector search into a graph database natively? And then two is, do you actually think there's ways to improve the way we embed things by leveraging relationships? Because right now, when you get an embedding, you just take the text chunk and then you generate an embedding based off of that. You were talking a little bit about like graph-based, like GNN-based models. And I'm kind of curious if you think there's advanced representations of embeddings that you could generate through leveraging those relationships.
Yes, we are thinking about this too, because we are trying to bring the graph database at the memory layer, at the persistent layer here. So after we persist most of data in a graphs centralized fashion, so that will bring us the ease to make the graph aware embedding also feasible. But we didn't explore this for now yet. But because we consider the RAG is the low-hanging fruits about graph plus large language modules. But in the future we can explore like the node to vector or even GNN based, because we have everything connected already. So maybe that kind of embedding can benefit some certain cases, because the connection were considered in that case. Yeah.
Awesome. And the last question I'll ask is, so what's next in your mind for this world of LLMs, graphs, and retrieval augmented generation? I'm sure you have a bunch of ideas for future work, and I'm curious to hear your thoughts and share them with the audience on some of these ideas.
Yes. So this is just a very this is just the very beginning of what we have been doing, in the community with you, Simon, Logan. So in our mind, we have the ambition to, fully exploit the knowledge graph in many ways. So this is just some intuitions in our mind. So one of them is we can do some because in LlamaIndex, for example, we have some sort of like flare or guidance-based sub-question abstraction. So we can do different fashion of the chains of thought approach. So to break down the long task or long queries. So maybe somehow, because we can define some the proven approach of those breakdown patterns. And that pattern can be, by nature fit in a graph fashion. So if we put those, proven patterns in graph, so maybe combine those existing effective patterns. So the breakdown itself can have some hidden connections. So maybe we can have some result on this part. So another is we are thinking of when we were talking about close to our partners or users or customers. So they were talking about some extremely hard long tasks. Like, for example, you give some context, you want the language module to help you generate a real world novel. So they were talking about and referring some of the papers that we need to somehow persist the memory structure in some way. So, and this memory structure cannot be in a simple structure. So to me, that will, at least in the first step, to fit into a graph pattern. So maybe we can, after we introduce the graph store, we can do such case task as well. So the final one is when we were talking about some real-world problems in their RAG applications, that in real-world problem, we cannot fit one single query engine or retrieval approach to fit all the problems. So maybe we can introduce different existing knowledge graph as some domain-specific query target, and to work together with some other, maybe some of tasks are related to some chart building or analytical things. So that can be where to different table RAG, so etc. So now we are actually drawing. Sorry. So this is just an initial draft that we were thinking maybe a quite relatively complex RAG workflow with LlamaIndex. So for example, we can create a LlamaIndex router in the beginning to detect whether it's a long question or not. So in case yes, we can do the breakdown. So for example, we can use the guidance integration of the LlamaIndex. And when it's break down into the short question, so we can define a router to fit different like a case when rule matching role. So and that can be routed into different target query engines. But finally, we can create a fallback role. And in this fallback role, maybe we can do some more expensive thing, and we can put all the approaches we have in a row. That maybe the cheaper one will be in the front, and we do attempts of the queries, and every step we will revisit if it can reach a threshold that we can return this query, or we can move to a next one, and we can finally cherry pick some of them or combine them. So this is just a initial draft that leverage the graph is one part of it, but with the orchestration capability of LlamaIndex. And so this is what in our head now. And on the other hand, the final one is we are thinking our ambition was to break the traditional graph database capabilities. We can introduce something more. For example, the vector search in NebulaGraph, and then we can make the connection between the trunk, the entity, in one picture, and we can search them not by the key matching or a full text search, also by the semantic embedding based search. So that's ambition in our head, and we are trying to make them soon to the LlamaIndex community. Yeah.
Awesome. This is great. I just want to make some time for two key audience questions. So first question is, how do you think graph databases fit within conversational AI engines where context like short-term memory is important? And so in a conversation where you want to maintain kind of short-term memory, I think Charlio responded that with an idea that you could add a timestamp to each node and edge, and then somehow like filter by recency when you actually do graph-based queries. But I'm also curious to hear your thoughts, Wey.
Yeah, that's a great question. We didn't explore this yet, but it's a great idea that because NebulaGraph have the capability to module the temporal graph, so we can do the temporal graph visualization and the queries. So yes, if we bring the time step into the picture, we can do a lot more precise or more complex task that's concern the time factor. Yeah, that's a great idea.
Cool. And then the next and probably last question is, I think an audience member asked, is NGQL, when you showed that example of the LLM powered graph-based QA, is the NGQL sentence generated by the language model? And maybe the higher level question here is can LLMs generate graph-based queries?
Yeah, it can. And as I showed in the LlamaIndex query engine, it can help us to generate, you just drop the neural language and you can get the query cipher query itself for you. We didn't choose to, the background here is NebulaGraph supports both ngQA is our proprietary query language and the OpenCipher. So OpenCipher is like more popular open query language. So we choose to generate the OpenCipher one. Yeah, for now. Yeah.
Gotcha. Makes a lot of sense. Okay, well, awesome. I know we're a little bit at time. And so I want to thank Wey for taking the time to speak with us and share this fantastic presentation. We'll share this recording on YouTube and also the slides as well, probably on LinkedIn and Twitter. And so, yeah, thank you all and happy Friday. And for those of you in the US, happy July 4th weekend.
Thank you, Jerry. Thank you.
Thank you.